Hey guys, just checking in. I hope everything is going well with distance learning. I wanted to create this video because after checking out the exit slips you guys have been turning in, I have found a common mistake happening throughout most of your work. And so I'm using this video to explain the difference of finding the hypotenuse versus finding a missing leg or one of those side lengths that is connected to your right angle. So let's dive in and check out some examples. All right, if you see here, I have two different examples up on the board. On this problem, we're missing this side length, and on this problem, we're missing this side length. When dealing with these types of problems, I first want you to ask which side is missing. So when we look at this example, we were given both of the legs. I know those are the legs because they're attached to that 90-degree angle. So therefore, the side that we're missing, or the side we're trying to find, is our hypotenuse. Since it is our hypotenuse, I know that I'm going to be solving for C. Your hypotenuse always represents C in your equation for the Pythagorean theorem. Now let's look at this example. We were given one leg. I know this because this side length is attached to my 90-degree angle, but then it also gave the hypotenuse. I know this is the hypotenuse because it is across from the 90-degree angle, or you can also think of it, it's the longest side on your right triangle. So I was given my hypotenuse, so the only other thing I'm looking for is the leg. Your leg is always representing A or B in your equation. It doesn't matter which one you substituted in for, as long as the other one that you didn't substitute in for represents that other leg. Now let me show you how to solve these problems step by step. So on our first example, we're trying to find C. That means that variable is going to stay there because that's the value we're trying to find. So I'm going to find values to substitute in for A and in for B. That's going to be our two leg lengths that were provided. Now it doesn't matter which one you plug in for A or B, just make sure that both of them end up in your equation. Now that I have substitute values in for A and for B, I'm going to go ahead and simplify the equation I have. So I have 28 squared. That means that I'm doing 28 times 28. Whatever this base value is, you are going to multiply it by itself 2 times. So this is doing 28 times 28. Same thing with the 21. You're multiplying 21 by itself 2 times. So we're going to do 21 times 21. You can also use the squared button in your calculator. Either way, just make sure that you're not multiplying 28 by 2 or multiplying 21 by 2. You're squaring it, so it's multiplying by itself twice. After squaring 28 and 21, I was left with 784 plus 441 equals C squared. I carried the C squared down because I haven't been able to simplify it just yet. So to continue on, I'm going to add 784 plus 441. That gets me 1,225 equals C squared. Next step, we are going to have to get C by itself. This is the last step of solving these types of problems. Since C is being squared, the only way to undo that is by taking the square root of it. So we're going to be taking the square root of C squared. But since we're taking the square root on one side of our equation, we have to do the same thing on the other side to maintain that balanced equation. After taking the square root of 1,225, you are left with 35 equals C. The reason we're left with C is because the square root undid that squaring, leaving you with just C. Therefore, this shows that our hypotenuse is 35 units long. Now I'm going to show you how to solve a problem where one of your legs is missing. We know that the legs are going to be substituted in for A or B. We know one of those is unknown because they only provided us with one of them. It doesn't matter which one you substitute in for A or B. I'm going to go ahead and substitute it in for A, leaving us with 15 squared plus B. B is that unknown leg length that we have. And then we know our hypotenuse, meaning we can plug in a value in for C. So that is 17 squared. From here, we are going to solve for B. In other words, we want to get B by itself on one side of the equation. So we can go ahead and simplify 15 squared and 17 squared. Remember, when you're squaring a number, you're taking that larger number and you're multiplying it by yourself 2 times. So this is the same as saying 15 times 15, and then this is the same as saying 17 times 17. After simplifying my equation, I was left with 225 plus b squared equals 289. I carried the b squared down into my equation, leaving it as is because I could not simplify it at this point in time. Now, I'm still trying to get b by itself on one side of the equation, meaning I'm going to have to move this 225 over to the other side. Since it is a positive value, to undo it, I'm going to subtract it. So I'm going to subtract 225 from this side to make sure b squared ends up by itself. But what I do to one side of my equation, I have to do to the other to maintain that balance. After subtracting 225 from 289, I am left with b squared equals 64. Now I'm going to go ahead and take my final step. I need to undo the squaring that is occurring with the b value. To undo something that is squared, we're going to take the square root of it. What we do to one side of our equation, we have to do to the other. So you're going to take the square root of 64. This will simplify to b because the square root undoes the squaring. And then the square root of 64 is 8. That means that our missing side length in our triangle is 8. Now, before I move on, I just want to show the differences between these two examples. The work is pretty much the same except for this step right here. If you look at this example, we had both of those values on this side of the equation, whereas in this example, we didn't. So the only difference in these two problems is when we're missing a side length or a leg, you have to subtract a value and move it over to the other side, leaving you with your variable on that side. Well, guys, I hope these examples cleared up any confusions you had when using the Pythagorean theorem. There's two different kinds of ways that you can solve these problems. It just depends on if you're trying to find the length of your hypotenuse or if you're trying to find the length of a missing leg or that side length that's attached to your 90-degree angle. Please feel free to ask me any questions through email or on the Google Hangout. I am available for one-on-one meetings as long as you schedule them with me. Let me know if you guys need any help moving forward with the Pythagorean theorem.